So now that you are really good at finding, that was almost a disaster. Now that you are really good at finding derivatives of, I can't even blame the cat for that because he's not here. You find the derivatives of x to any power. What if you had the derivative of sine x or cosine of x or e to the x or ln of x? There's a completely different set of rules that are going to govern that, but they always still come back to the limit as h approaches 0 of f of x plus h minus f of x over h. So to start this one about sine, cosine, and so forth, the first thing that we need is, as a preliminary observation, is what is the limit as h approaches 0 of cosine h minus 1 over h? All right, you should use a graph to determine that. So why don't you pause the video right now and determine this limit using a graph. Okay, so hopefully you're back and you've come up with an answer to that. And I didn't work this out beforehand, but I guess it won't cost me too much time. So I'm just going to go ahead and do this. It's cosine x minus 1. By the way, let's observe that you cannot evaluate this by substitution. So if I put in 0 for cosine of h, what's cosine of 0? It's 1. Yeah, so I have 1 minus 1, which is 0. And of course, my denominator is going to 0, so I have 0 over 0. So this graph is going to have a hole that the calculator is not going to show me when x equals 0. Now, we have cosine, so probably we're not going to need anything much more than like -2 to 2 on our windows. But I think I'm just going to start with a standard window and then zoom in. So our standard window isn't showing much. It's a little bit of a waste of time to do that. But that way I can just go zoom in, and you have to hit enter again, and then I can see what the graph is really doing. It's passing through the origin, but we know that this graph actually has a hole at 0, 0, but you can clearly see that the limit is what? It's 0, yep. Now, looking at the graph does not prove that the limit is 0, and we're not going to prove the limit is 0. We're just going to take my word for it. Sometimes we do that. Okay. Now, the next thing that we need in order to evaluate this limit. Oh, I guess we're going to do something else a little bit differently first. I'm going to show you a cool thing your calculator can do. Your calculator cannot tell you that the derivative of x squared is 2x, but it can graph that. Let me show you what I mean. So if I clear this function, I'm going to graph the function x squared. And this is going to be really useful for exploring derivatives of functions that you don't know the derivative of. So what we do is we do math 8, scroll down to 8, and it says n-derive. All right, so when you do that, you get this nice syntax. If you have an older calculator, it might not give you the nice syntax, and then you have to look it up on YouTube or ask me if you need to. So DRX, now, by the way, I could be very cool here and put var's y1, and then maybe I'll do that. Var's, because I'm going to change that function. Y var's y1. So this is going to be the derivative of the function I have in y1. All right. Now, your calculator can evaluate a derivative at a specific point, but I want it to evaluate at all points. So I'm just going to put, for my x equals, I'm just going to put x there. Now, when I graph it, and let's see, this is x squared, so I'm going to zoom 6 on this. When I graph it, my first graph is going to be x squared. My second graph is going to be the derivative of whatever that first graph was. So here's my graph, and there's a lot we can do and are going to do in terms of how these graphs are related. So there's y is equals x squared, and here comes the derivative. And so I can sort of, if I looked at that very carefully, I can tell that's a linear function, and I could figure out that it's y equals 2x. All right, that's using a function that you know the derivative of. Now, suppose I go back here to the y equals, and I change this function, and I make it sine of x. So sine of x. So now we'll get at least sort of an idea what we think the derivative of sine of x is. So the first graph is going to be sine of x. Now look at what I've got here, the derivative of y1. So the derivative of whatever that graph is going to show up as my second graph. Let's see what it looks like. Oh, let's graph it. And excuse me. By the way, I'm going to set up the window on this one a little bit. I guess I can do -10 to 10. I may could do -2 pi to 2 pi. But for my y min and y max, I know I'm just dealing with sine and cosine. So I'm just going to go -2 to 2 on that. All right. And then we'll go ahead and graph that. So here's sine of x. That's the sine of x you're all familiar with. Now here comes the derivative of sine of x. So what is being graphed now is the derivative of sine of x. What function is that? that the derivative of sine of x turned out to be. Well, let's go and turn this function off. So we're going to turn off the sine of x because it's distracting and just look at our derivative. This is the derivative of sine of x. What function do you think it is? All right, well, in the next video, I'm going to tell you what the function is, and we're going to prove why it is that.